once again with you with the new video lecture. In the last video lecture, I explained you about the simple microscope when the image is formed at D, at least distance of distinct vision. In this new video lecture, we will discuss about another case of image formation when the image is formed at infinity. I really appreciate your interest in watching all these videos that I can see, but don't forget to like, share and subscribe my channel if you have not. Don't forget to press the bell icon button so that you get the notification of every new video lecture. Thanks for being with us. Keep watching, keep learning.
So, my dear friends and my dear learners, in the last video lecture, you have seen the case of image formation by simple microscope when image is formed at D. In the second case of image formation by simple microscope, the image we are considering to be formed at infinity. So again, it will be quite interesting and logical also that how a virtual and magnified image can be formed at infinity, because we know when the convex lens is used and if object is placed at focus, then only the image is formed at infinity. So I will tell you a few more new things here that will definitely help you to learn the concept easily. For the purpose, I am taking here the convex lens once again, as we have taken in the last case. So this is the convex lens we are using as a simple microscope. This is the vertical symmetrical line. This is the principal axis. This is optical center. This is principal focus. The same distance we will use on the right side also. So now the very important part of this topic is where the object should be placed to have the image at infinity, because we know image formed at infinity is always real and unit, and the object is placed at focus. So if we place object very close to the focus, that is still it is lying between focus and optical center, but not exactly at the focus. So let us see what happens in this case. The first ray we are taking parallel to the principal axis. This ray will pass through the focus after being refracted through the convex lens. If you produce it backward, you will get the dotted line like this. The second ray we are taking passing through the optical center, and you can see these two rays are looking like two parallel lines. So one thing is clear, that the image will not be formed. Really, we cannot locate the image at any position, but since we have taken the position of object between focus and optical center, so from the concept we can say the image would be virtual and erect. That is important to understand. So this is what, again, theta I. What theta I is? Angle subtended by image. So this time angle AOB is equal to theta I, because this ray is also, you can say, associated with the image wherever it is located. Let the same symbol we are using for image is A dash B dash. So wherever it is located, that angle is made by that image also. Then we want to have theta O also. If you could remember, in the last case we have taken the definition of angular magnification, and the angle subtended by object is used when it is placed at D. So let this location is A dash as we had taken in the last case, and this distance is capital D. So again we will cut an arc equal to the size of object. Let that point is still the same one, C. So if you join this C to the optical center, this angle would be theta O. So angle A dash OC is equal to theta O. Now we have to deal with the term angular magnification. So this time also m is equal to theta I upon theta O. So what theta I is? Angle subtended by image formed at infinity. And what theta O is? Angle made by object placed at D and seen directly. So the rest terms will be dealt as it is, as we have done in the last case. So we will have here tan theta I is equal to AB upon AO. For a small angle, this tan theta I would be equal to theta I. So theta I is equal to AB upon AO. Likewise, we can write for tan theta O also, and that tan theta O is equal to A dash C upon A dash O. So theta O is equal to A dash C upon A dash O, but A dash C is equal to AB, and therefore theta O is equal to AB upon A dash O. Then if we use this equation number 1, and then we will have m is equal to AB upon AO upon AB upon A dash O. That can be written as AB upon AO into A dash O upon AB. So this AB would be cancelled. Yes, definitely. So A B C D cancel हो गया. So M is equal to A dash O upon AO. You can see A dash O is what? Minus D, and AO is equal to F. Here A dash O is equal to minus D, and AO is approximately minus F. Then M is equal to D upon F. So this is the formula for angular magnification of simple microscope when object is placed such that the image is formed at infinity. Now you can compare these two expressions. This is angular magnification for image at infinity, and in the last case we had angular magnification for image at D. We have M is equal to 1 plus D upon F. So we have two expressions for angular magnification for simple microscope, and these two are D upon F and 1 plus D upon F. So you can see in which case magnification is more. When image is at D, the magnification is more, and that is 1 plus D upon F. It is more than 1 than when the image is formed at infinity. But even though we consider the most appropriate mode of image formation is image formed at infinity, because it is the least strained mode of vision. In this case, the strain on eyes is less. So despite having the angular magnification less than by 1, we prefer image formed at infinity. So in that way you have seen that the simple microscope is used in two ways: when image is formed at D and when image is formed at infinity. So I hope you understood the concept of simple microscope, and it is used to see the magnified image of small size object, but it has limitation. It cannot magnify up to all extent. So for getting higher angular magnification, we use compound microscope. So in the coming video lectures we will discuss about the compound microscope. You will learn the things in detail, that how this compound microscope is designed, and how we are using the compound microscope. So I hope you enjoyed the learning. Keep watching, keep learning. If you have not subscribed my channel, like it, share it, and subscribe it. Don't forget to press the bell icon button so that you will be updated when the new video lecture is uploaded. So thank you very much, learners, for your patience, full watching and hearing. We will meet very soon in the next lecture. Bye. Keep watching, keep learning. Thank you.